Hello everybody, welcome back to this presentation by Peter Palomaki from Palomaki Consulting. And Peter's going to give us a presentation on electroluminescent progress and roadmap. As always, please do leave your questions in the sidebar and we will take these live at the end of the presentation. I'm going to turn off my camera now and hand over to Peter, and then I'll reappear at the end to take your questions. Over to you, Peter.
Great. Thank you so much, Chris. And thank you to Chris and Kasha and everybody at TechBlick for inviting me to speak today. I'm excited to share with you my view of the world in terms of electroluminescent quantum dot LED. So I'll tell you a little bit about where that technology is today and where it's headed. And I hope you enjoy it. So a little update on myself and my company. I'm a consultant mostly in the quantum dot field, all things quantum dot related. My background is in materials chemistry. I have a PhD in chemistry, and I have for the last 4 years worked with companies around the world on all things quantum dot. So I encourage you to reach out to me or connect if you're interested in learning more. So today I will touch first on an overview of the technology. What is electroluminescent quantum dot LEDs and how are they different from photoluminescent quantum dots, which most of you are probably familiar with. I'll touch also on regulations because I think a lot of people that I have conversations with are interested in what's going on with cadmium and lead and RoHS and things like that. So I'll spend a little bit of time on that. And then I think it's important for us all to get on the same page in terms of metrics, how we characterize these devices, these electroluminescent quantum dot devices, and so that when you see data in the industry presented or in papers, you can understand what it means. And then I'll have a few examples from 3 companies of the current status and where they are today, 3 of the leading companies in this space, and then future directions for quantum dots in general in all display technologies. So this is mostly going to be display focused, although of course quantum dots can also be used in lighting and other applications. And I'm going to assume that most of you understand generally how quantum dots are used today and their benefits. So I won't spend too much time on that. And I know there's other speakers today that are going to present on quantum dots. So I'll leave it to them to give you more of the background if you're interested. Photoluminescent quantum dots operate as optical down converters. This is the type of quantum dots that you see in a Samsung or any other brand QLED TV. This is the quantum dot. It has a core in the middle, a shell, and these ligands on the outside. And its basic operation is just simply an optical down converter. It takes blue light and converts that into red and green. And that's dependent on the size and the composition of the quantum dot. Any TV you buy today that is branded as a quantum dot TV has in it an optical film like this that spans the entire area of the TV. And in that optical film, the quantum dots are embedded in a polymer matrix, sandwiched on either side by 2 support films that also act as barrier layers to prevent oxygen and moisture from reaching the quantum dots, since they're sensitive to these materials, since they're sensitive to atmosphere. So this is how all displays that are out there today operate in terms of quantum dots. Future quantum dot displays, and this is kind of the next generation technology, if you will, and I'll provide you a summary of all of those at the end. But I'm looking really forward-looking today in my talk at electroluminescent quantum dot LEDs, so EL-QLED. And instead of optical down conversion, it's not a photon coming in being converted to a different color. It's electrons. It's electricity coming in being converted to photons. It operates the same way a normal LED operates. The LEDs that you would that are in the backlight of a TV today, or that you would buy at Home Depot or for lighting, the operating principle is the same. Electrical input, photons out. The only difference is the active layer here is now quantum dots instead of a monolithic semiconductor. And of course, there's many other layers involved here to efficiently transport electrons and holes to the quantum dot layer where they actually combine and generate light. And you can see a couple of examples here, one from NanoSys, one from Samsung, where they've made these devices. You can operate them with a battery or on electricity. And the color is, of course, tunable based on the quantum dot that you use. So this is the type of quantum dot application that I'm going to be talking about mostly today, is the electroluminescent. You'll hear plenty of